before we go on to example 2 in 3.2, I want you to see a little bit about how the multiplicity of zeros of each of our polynomials in a rational function will affect the graph. So instead of it being a touch or cross the x-axis type of situation, instead it helps us determine what direction the branches of the graph are going. So let's look at each one of these. Here is graph A. This came from an online homework problem from a few years ago. I don't know if this is even part of the homework online anymore, but I still think it's valuable to kind of note this situation. So, according to what I have here, graph A goes with this equation here. We've got a horizontal asymptote at y equals 0 because the degree on the top is 1 and the degree on the bottom is 2. So there's our horizontal asymptote. We have a vertical asymptote at B, whatever value that is. So this is just assuming that B is at a negative value, so there's where our asymptote would be in there somewhere. Now the important thing is to note that we have this multiplicity of 2. Notice how both ends of the graph are going the same direction. Same end behavior on each side of the vertical asymptote means even multiplicity. So this has an even multiplicity of 2, so the end behavior of the graph on each side of the asymptote is the same direction. Let's look at graph B. This is basically just our reciprocal function, only it's been reflected, and we saw that in section 3.1. So this actually matches up with our first equation. We just have a multiplicity of 1 on each branch of our graph. The degrees are the same, so the horizontal asymptote is at 1 because it's the leading coefficients divided, so 1 divided by 1, horizontal asymptote at 1. The vertical asymptote is at B, and then we have each branch of our graph. The ends of the graph are going in opposite directions around that vertical asymptote. This one up and this one down, because the multiplicity here is just 1 on each of those zeros. Look at our graph C. Graph C has a multiplicity of 2. On this bottom 0 is the one it specifically applies to. But the top 0 is also affected by a multiplicity of 2. Notice how it's touching the x-axis and jumping back up, kind of like it would a parabola that was touching the x-axis. So that's why that happened, because of 2 multiplicities here and here. So we've got the degree on the top is 2, the degree on the bottom is 2, the degrees are the same, the horizontal asymptote is the leading coefficients, which again is 1 divided by 1, so our horizontal asymptote is at 1. But because we have that squared in the denominator, our pieces of our asymptote are going the same direction. And because of the multiplicity in the numerator, we've got it touching the x-axis. D is this last one here. Again, we've got the graph touching the x-axis at point A because of that multiplicity of 2. And then we have a multiplicity of 1 in the denominator, which means these are going opposite directions around our asymptote. And then this has our third type of horizontal asymptote, which is no horizontal asymptote. This one has a slant asymptote, diagonal or oblique asymptote. There's different names for that, but basically it all is saying the same thing. It's slanted, and that comes from the fact that the degree in the numerator is larger than the degree in the denominator, and we'll learn more about that in section 3. Okay, with that in mind, that took a few minutes to talk through, and I'm sorry that's not in your notes. Let's go ahead and follow these steps. Uh-oh, I didn't mean for this picture to be all expanded. We've cheated now and seen our answer. Let's go back and pretend we don't know what that looks like. Okay, step 1, factor. So that will give us g of x equals, and I'm going to do this weird thing. I don't know if I need to, but it's just making me feel like I want to. So g of x is equal to, factor out a -1. You don't need to write the 1. It can just be a negative. And then instead of 2 minus x, I'm going to call that x minus 2. And in the denominator, I can factor out an x, from everything. That leaves me with x squared minus 6x plus 9, and that is a perfect square trinomial, which means this can be factored further. Turns out this negative isn't going to be so important, but I already took it out, so I'll just leave it. That turns this into x minus 3 squared. So see, we have that multiplicity in the denominator, which is going to create that same end behavior around the vertical asymptote. Okay, nothing reduces, so we don't have to do anything else to find the vertical asymptote. So let's go ahead and do domain. So domain would be x cannot equal 0. Oops. And x cannot equal positive 3. So because of that, we have a vertical asymptote. I know I'm skipping intercepts for a second. We have a vertical asymptote at x equals 3 and at x equals 0. So that puts one right here and another one here. So keep in mind that because this one has a multiplicity of 2 around this asymptote here, this multiplicity of 2, that means our pieces of the graph are going to be going the same direction around that asymptote. So they'll either both be going up or they'll both be going down. Okay, so I skipped a step. I skipped the intercepts. So let's go ahead and find the intercepts. I'm going to set the numerator equal to 0. I didn't really need to take that 0 out, or the negative out. I'm just going to go back to my original problem. 2 minus x equals 0. That means 2 equals x. So we have an x-intercept at 0, no, at 2, 0, correct? 2, 0. So over 2, up 0. There it is. Then for our y-intercept, we will have 2 minus 0 over 0, 3 times 0, no wait, that 3 is not there. So 2 minus 0 over 0 cubed minus 6 times 0 squared plus 9 times 0. Uh-oh, that's causing us to divide by 0. We can't do that, that's undefined. Obviously, if we thought about our domain earlier, we would know that x can't be 0, so there is no y-intercept. So even though sometimes our graph can cross a horizontal asymptote, it will never cross a vertical asymptote. Next, we are going to plug in some other points. Nope, I skipped ahead. We didn't do horizontal. So our horizontal, we have degree 1 over degree 3. So that means y equals 0. That's our horizontal asymptote. So let's just throw that in there. Obviously, if we have an x-intercept on an asymptote, it's going to cross through there. Let's plug in some other points. Let's do 1 on each side of the asymptote. So 1 at -1, 1 at +1. We might want to do 1 at, oh, I didn't mean to write it there. 1 at -1, 1 at +1, so I have each side of this asymptote. And then we might want to have one that's on this side of our intercepts, so maybe 2.5. And then another one past this asymptote at possibly about 4. Definitely just use a calculator to plug these numbers in. So let's see, plug in a -1, I get 2 minus -1, which is 3. And then I get -1 cubed minus 6 times 1. So -1 cubed is -1. Minus 6 is -7. And then -9. Gosh, this math is hurting my brain this late in the afternoon. So I think we got a -16 there. The most important thing about this number is that it's below the x-axis. That's what's important. So -1, we're down here somewhere, just a little bit. Okay, let's plug in 1. So 2 minus 1 is 1. And then 1 cubed is 1 minus 6 is negative 5. Plus 9 is positive 4, so 1/4. So at 1, it's going to be 1/4, so a little bit above the x-axis. Let's go ahead and plug in 2.5. My numbers have all kind of jumbled together. That's annoying. Okay, got it. So now we're going to go 2.5 into our original problem. So 2 minus 2.5 is negative. And then 2.5, oh, this is getting harder to plug in. Anyway, this is going to give us a negative answer, I'm pretty sure. I'm going to make a guess that it's going to give us a negative answer. So this was a negative, this was a positive, this one's a negative. Now let's try 4. So 2 minus 4 is negative 2. And then 4 cubed, big number, minus 6 times 4 plus 9 times 4. Pretty sure this is going to be a positive number. Let's go ahead. I'm going to throw it in a calculator really fast. Just I'm doing too many assumptions here. So let's go 4 cubed, right? Minus 6 times 4 squared, so that's 16. Plus 9 times 4. That came into 4. Did I type something in wrong? So 4 times 4 times 4 minus 6 times 4 times 4 plus 9 times 4. Yeah, I got 4. Okay, so that gave us a value of 4. But we're taking negative 2 divided by 4, so that's negative 1/2. That makes sense. So at 4, we're going to negative 1/2. Over here, we're going somewhere negative. We're not sure where. We didn't calculate it. Now let's go ahead and kind of guess where these branches would be and talk about the multiplicities. Again, we've got another time when our graph is crossing through the horizontal asymptote. So notice how right here we've got the end behavior of our graph going both down around this asymptote, and that's because of the multiplicity of 2. So they're both going the same direction. Okay, let's check that with the graph from the graphing technology. I'm going to go ahead and make this just full screen. Looks pretty good to me.